Namaste, Hamisha Khush Raho Betiya. My name is Manisha Singh. Today I am teaching you dairy industry byproducts. Now let's start with the topic. First of all, what is dairy byproducts? The dairy byproducts may be defined as a product of commercial value produced during the manufacture of a main product. Skim milk, buttermilk, ghee, residue, and the whey are the main dairy byproducts. The utilization of dairy byproducts improves plant economy, makes valuable nutrients available for the humans, and reduces environmental pollution originating from the dairy waste. Conversion of edible substances into the non-food items is not ordinarily justifiable, especially in the countries where there is an overall shortage of milk supplies. It has always been realized that economic disposal of byproducts is an essential prerequisite to profitable dairying. Each and every component of milk must be judiciously processed into edible form for the obvious reason of its unique nutritional value. These byproducts are therefore receiving increasing attention for their proper utilization by the research workers all over the world. However, it should recognize that just because it is technically feasible for any dairy byproduct to be processed into the interesting byproducts, it does not mean that we can utilize it. Processing of byproducts needs to be economically feasible if one is to invest capital and resources into the program to utilize them. Therefore, further emphasis needs to be put on cost effective processing and utilization technologies of dairy byproducts. In some countries like India, the most of the problems associated with the production and utilization of dairy byproducts are a low per capita availability of milk, higher proportion of buffalo milk, poor quality of raw milk, lack of organized manufacture of products, lack of adequate technology, high cost of new technologies, lack of in-house R&D, lack of proper infrastructure, lack of indigenous equipment and plants, etc. Before setting up a byproduct factory, it is important to consider the economical aspects of the plant, because sometimes the cost of manufacture of the byproduct may be more as compared to the byproduct, and therefore the setting up of the byproduct plant is not economically feasible. But with advancement in science and technology, as also the automation of plants, the economic feasibility of these can be improved. First byproduct is skim milk and its byproduct. Skim milk is produced by the separation of cream from milk in dairy processing. Skim milk is rich in solid, not fat content, and is used for standardization of milk, preparation of skim milk powder and coffee whitener. It is regarded as a byproduct only when it is either not economically utilized or has to be utilized for the manufacture of derived byproducts like casein in small quantities. Next is casein and caseinates. These are prepared from skim milk and used in the food preparations, specialized foods and manufacture of plastics, etc. The technology of production of caseins from cow milk is well established, but when the milk is from buffalo or other animal origin, some technological modifications are required in the manufacture of casein from them. The R&D work on this aspect is very limited and is not available freely. This has been one of the limitation for production of edible casein from milk sourced from animals other than the cow. Further, it is very difficult to control all the processing parameters when this product is manually prepared. For good quality product, large mechanical and automatic plants have been developed. For using these plants economically, there has to be some minimum handling of milk of about 2 lakhs liters per day. Also, there should be facilities for proper utilization of whey that emerges in large quantity. Unless these conditions are met, casein production may not be techno-economically feasible. Additionally, in many countries, the technology and manufacturing plants need import that is costly and not all the time convenient. The economic constraints for the production of spray-dried caseinates are there: high drying cost, low bulk density, and high packaging, storage, and transportation costs. Next is co-precipitates. The technology of production of co-precipitates from skim milk is well established all over the world. However, their poor solubility, especially of the high calcium co-precipitates, has been mainly responsible for their non-acceptability and so non-production on commercial scale. Next is protein hydrolysates. They are the protein hydrolytes are the breakdown products of protein in the form of peptides and amino acids as a result of hydrolysis of protein either by acid, alkali, or proteolytic enzymes. Acid and alkali hydrolysis of protein results in complete or partial destruction of some and racemization of most of amino acids. These processes also pose problem of removing residual acid from hydrolysates. Bitterness, which is natural consequence of enzymatic hydrolysis of protein, is the main hindrance in the production of an acceptable protein hydrolysate. Expert specialized knowledge of different available proteolytic enzymes is necessary for developing good quality protein hydrolysates through enzymatic hydrolysis. Next is whey and its byproducts. Whey, the greenish translucent liquid, is obtained during the manufacture of the cheese, casein, chena, paneer, chakka, and co-precipitates, and has been viewed until recently as one of the major disposal problems of the dairy industry due to the presence of significant amount of organic matter in the form of protein, lactose, fat, minerals, and water-soluble vitamins. Its disposal causes environmental pollution. The biological oxygen demand of whey is very high, constituting a major economical burden to be disposed as a waste material. The quantity of whey produced is sometimes not sufficient to utilize it economically. Hence, the utilization of whey is not taken up in a significant way in such circumstances. Next is whey drink, a variety of whey-based beverages consisting of plain, carbonated, alcoholic, and fruit-flavored have been successfully developed and marketed all over the world because they hold great potential for utilizing the whey solids. The predominant types of new whey drinks are based on the blends of fruit juices and whey, and the other types of whey containing beverages currently available on the market in various countries include products from deproteinated milk serum, fermented dairy type beverages containing whey, and flavored milk type products containing whey or whey components. Whey drinks contain valuable and nutritious whey proteins but do not have large market value, and they can be utilized only on small scales. Technological problems may be encountered also when the desired formulation contains additional components that interfere with processing or final product quality. Flavor losses with some fruit juices containing whey drinks may be encountered in UHT processing of the product, especially in the direct type machines employing a flash cooling vacuum chamber. Next is concentrated and dried whey. Drying extends the shelf life of the whey and simultaneously reducing its weight and volume. This reduces the cost of transporting and storing the product. The advantage of processing whey into the product powder is that there are no byproduct residues to be treated separately. Basic disadvantages include expensive equipment and energy, both of which requires a large processing capacity yet demand relatively low prices for the final product when compared to other products such as whey protein concentrates. Ultrafiltration, the evaporation of large quantity of water to convert the whey to dried form is found to be uneconomical with the conventional evaporators due to high evaporation cost. In the manufacture of dried whey, more than 50% of energy is consumed is required at the evaporation stage. Therefore, the cost of energy required for the evaporation of whey is a major factor determining the production of whey powder. Hence, it is important for the economic production of whey powder to ensure that evaporators are operating at their maximum capacity and efficiency. Next topic is ultrafiltration processing of whey. Separation of whey proteins is typically achieved by the ultrafiltration or difiltration to produce whey protein concentrates, which have many applications in the food industry. By ultrafiltration process, a highly functional whey protein concentrate is produced as the primary end product for a wide variety of applications as a substitute for non-dairy, non-fat, dry milk, and other protein ingredients. Increased production of whey protein concentrate warrants its greater application in food products. Next type of byproduct is demineralized whey. Ion exchange and electrodialysis processes are used to demineralize whey, and these processes can be utilized only for large scale operation, and their high capital cost, high running cost, and problem of resultant affluents are the main limitations of these processes. Economic feasibility of production of demineralized whey lies in the utilization in value added products only. Next is lactose. Lactose production from whey can be economically feasible only when it is produced on large scale. Generally, sweet whey is preferred because of its high lactose and low ash content. In case of acid whey, neutralization is necessary. This will change the whey characteristics and also increase the cost of manufacture. Lactose can be produced by using ultrafiltration permeate as a raw material, but UF permeate, particularly the acid whey permeate, has a very high calcium content, and removal of approximately 50% calcium is necessary to avoid difficulties during evaporation, which makes the process costly. Next is Next type of byproducts are milk mineral products. These products are prepared by precipitation of calcium phosphate in the whey UF permeate under suitable conditions of concentration, pH, and temperature and time. The crystals that first precipitate quickly undergo solid state transitions depending on the conditions to which they are subjected. It is necessary to grow calcium phosphate particles in sufficient size to recover them in a good yield by centrifugation and filtration. Milk mineral products rich in natural calcium and phosphate are valuable nutritional supplements in today's osteoporosis sensitive world and are used as a natural calcium supplement in the growing range of food products including milks, yogurts, canned milk, powders, and confectionery and health foods. However, their commercial productions need further boost. Next is buttermilk. Buttermilk is the byproduct of the butter industry, and buttermilk is produced when butter is made by churning cream or whole milk curd. Buttermilk as a byproduct has very important place in dairy industry and needs proper attention for its judicious utilization. The high nutritional value of buttermilk and increasing public awareness concerning the environmental pollution warrants for the economic utilization of this important byproduct. Sweet cream buttermilk that is produced in organized sector is preferred for processing and utilization in different products. The spray dried buttermilk powder is less free flowing and dusty because of the high fat content in comparison with the skim milk powder. The high fat content reduces the shelf life of the powder during the storage. Desi buttermilk is an important domestic beverage, but it is mainly produced in the unorganized sector in small and scattered quantities and is mostly utilized at the domestic level. Next type of byproduct is ghee residue. It is a brownish sediment obtained by the filtration of ghee after heat clarification. Major portion of ghee residues in India is obtained in small quantities and particularly has scattered small scale household production of desi ghee in villages which remains unutilized. Ghee residue from ghee produced at organized sector or at commercial level can be utilized for the manufacture of chocolate burfi, samosa filling, etc. But potentially of it full utilization is yet to be explored. Hope you all satisfied with this session. This session is powered by Digital Version 2.0 Jyoti Vidyapeeth Women's University Jaipur. If you have any query, please mention in a comment box. I will resolve them whenever we have a live session. Thank you so much for watching this.